Okay, so let's do 7.3. Two polygons. This one's a vocab question. Very important though. Two polygons are similar polygons if corresponding angles are congruent and corresponding sides are proportional. We should know this. This is very important, okay? Remember that congruent polygons are if they have the same angles and the same side lengths. Similar polygons they need to have congruent angles as well as proportional side lengths. Okay, so let's take a look at this. List a pair of congruent angles and the extended proportion that relates to the corresponding sides. So, very important, this little symbol right here, this swiggle line, tells me that this triangle and this triangle are similar. So if they tell me that the triangles are similar, what do I automatically know? I know that their angles must be congruent, that their corresponding angles must be congruent. How do I know that these are the corresponding angles? Because Q is to X, Q to X, R is to Y, R to Y, and S to Z, S to Z. We already learned that like chapter 3 or something like that. Okay, and now the extended proportion. What is one side length of the triangle to the other side length of the triangle? Well, I know QR is to XY. QR is to XY. That has to be equal to the proportion of RS to YZ. RS to YZ. I don't know why they didn't do it in order, which is fine. Then the next one is SQ to ZX, or QS to XZ. It doesn't matter, right? We already talked about this. We know this, okay? In the exam, if you put this as SQ, it won't mark it wrong, okay? So it doesn't matter, however you guys want to do it. As long as you understand QR to XY, RS to YZ, and SQ to ZX, okay? All right, so determine whether the polygons are similar. Okay, so because we don't know, they didn't give us like a G, E, H, D is similar with the swiggle. We can't assume that. So we have to take a look at the corresponding sides. So at the corresponding angles and sides. So is E congruent to L? Yeah. G congruent to R? Yeah, because of the arcs. H congruent to Q? Yes. Is 90 and 90? Yes. So we know that the angles are congruent. Now we have to figure out if the side lengths are proportional. So, and right here, we write R is to G, correct? Because didn't we just show that? R is to G. So we have to match here to here. So P to D, P to D, and so on and so forth. So now, after we write which angles are the possible, because we still don't know if it's congruent, but if it were congruent, this is gonna be, if these two polygons are similar, this is going to be how we express those polygons. RPQL is similar to, and then you just match the corresponding. Which one has, R has how many arcs? 2 arcs. So G must have 2 arcs. Or if this wasn't here, if this was blank, like let's say this was blank, right? This was blank, and they're telling you, okay, look, buddy, question A, if they are similar, we need you to read it like this. And then we can say, okay, cool. So R has how many arcs? 2 arcs. What else has 2 arcs on the other polygon? G. What about P? P has the right angle, so D has the right angle. What about Q? Q has the 1 arc, so H has the 1 arc. L has the 3 arcs, E has the 3 arcs, so G, D, H, E. And is that correct? Yeah, G, D, H, E. So now it's our job. To take a look and see if the side lengths are proportional. So RP to GD. So let's write that. I'm gonna erase this, okay? What is RP? RP is 8, and GD is 12. Okay, that should be equal to the proportion. What's the next one? PQ to DH. So what is PQ is 4, DH is 6, okay? Now that proportion should also be equal to the QL to HE. So what's QL? 6. And what's HE? 9. That should also be proportional to LR to EG. So LR is 8 and EG is 12. So now if all of these proportions, if this is equal to this is equal to this is equal to this, then we know that the side lengths are proportional, and then we know that, and we already concluded that the angles are congruent, okay? So another way of writing 8 over 12 in the simplified version is, what is it? 2 over 3, because the greatest common factor is 4. What's the greatest common factor of 4 and 6? 2. So 2 over 3. Greatest common factor of 6 and 9 is 3. So divide by 3, divide by 3. And the greatest common factor, once again, we just did this one over here, right? So it's going to be also 2 over 3. Now, are these proportional? Yes, these are true proportions, correct? Correct, correct. So now we know that, in fact, it is similar. And what's the scale factor? The scale factor is 2/3. We just did it, okay? Okay. So now, determine whether the polygons to the right are similar. Okay, so they're trying to trick us by like, oh look, congruent, 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 congruent. So all the angles are congruent, so they must be similar. But remember, the proportions, the sides must be proportional. So 20 is to 16 as 16 is to 12. 16 is to 12. Now, you could simplify this and see if they are, which is fine. You can do that. But if you have your calculator, you can also just cross multiply. And we know if the cross multiplication is if the answer for the cross multiplication is true, is equal, then you know that the proportion is also true. So what's 20 times 12? 240. Is that equal to 16 times 16, which is 256? Are those equal? No, so it's not a true proportion. So even though the angles are all congruent, the corresponding angles are all congruent, you do not have proportional side lengths. So if you don't have proportional side lengths, then your figure is not similar. So the answer is no. So this is not true, this is not true. No, no. No, because corresponding angles are not congruent. No, that's wrong. They are congruent. No, because lengths of corresponding sides are not proportional. That's my right answer. Okay? So let's take a look at this one. Determine whether the polygons to the right are similar. If so, write a similarity statement. Okay? So, excuse me. Okay, I know I have some congruent corresponding angles. I have A to P, B to Q, and C to R. So they gave me a bunch here. So I have to just look, and let's start crossing off what cannot be the answer. Because we know that if they're similar, look, they're concluding that all these triangles are similar. If they are similar, then that means the A to P must be congruent. A to Q must be congruent. A to P must be congruent. A to R. So we know that they all can't be congruent. A can't be congruent to everything. So one of them has to be wrong. So let's start cutting off what I know is wrong. So A is the, what is A? A is the right angle. So what's the right angle over here? P. Okay. So I know that this is, the first one is still good so far. Okay, is B to Q? B is the 1 arc, Q is the 1 arc, C is the 2 arc, and R is the 2 arc. So that's good. So that means this is automatically wrong, and this is automatically wrong. Okay? And I know that these two have to be wrong because it is similar. Well, I guess we can't say that yet. So let's actually take our time. Well, we know this one's wrong. No, because corresponding angles are congruent. They are congruent. We have it right here. Okay. So now, is B congruent to R? B is one arc, R is two arcs? No. So just to double check that we can cross this one off. So wrong, 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 wrong. So now, the only thing, so now we've already shown that the corresponding angles are congruent. Now we have to write if the corresponding side lengths are also congruent, proportional, not congruent, proportional. So what is the first one we want to do is AB to PQ. So what is AB? AB is 14, and PQ is what? PQ is 7. That should be equal to BC to QR. What is BC? BC is 50. QR is 25. CA, what's CA? CA is 48. And RP is 24. So now let's find the simplified version of this to see if these proportions are, this is a true proportion. So 14 over 7, that's just 2 over 1. Greatest common factor is 7. 50 over 25, greatest common factor is 25, so 2 over 1. 48, 24, 2 over 1. So not only are these triangles similar, but the scale factor is also 2 over 1. So A is your correct answer. Okay? Now, this one, you're gonna have to set up your own proportions. So the polygons shown are similar. Okay, so they helped me out. They told me that these two polygons are in fact similar. So what does that mean? So in order to find X, and to find Y, and to find Z, which are all side lengths, I'm gonna have to set proportions from one polygon to the other. So let's find our X first. So where is my X? Right here. And what is my X? My X is from the one arc to the no arcs. So that means this X is gonna be similar, is gonna be proportional to which one? One arc to the no arcs, to the 15. So that means X is to 15 as what? Now, pick any one of these sides. So if I pick this 4, one arc to the 2 arcs, what is the proportional one on this side? 1 arc to the 2 arcs. Yeah, but this is a Y. So why would I put 4 over Y? How's that gonna help me? It won't. I cannot solve for 2 variables at once. So what about if I did 3.5 and Z? I'm gonna have the same problem, 3.5 and Z. I can't solve for this Y unless if I have another variable. So I'm gonna have to choose no arc to no arc, no arc to no arc. So it's gonna be 4 over 12. Now I'm gonna cross multiply. So 12x, I'm gonna multiply the extremes, then the means. 4 times 15 is 60. What is 60 divided by 12? Should be 5. Yep, and my X is indeed 5. So now let's solve for my Y now. So my Y, once again, my Y is from 1 arc to 2 arcs. So 1 arc to 2 arcs. So I'm gonna have Y to the what, 4 is equal to, oh look, I can do, once again, no arc to no arc, no arc to no arc. So 4 to 12. 12. Now I'm gonna cross multiply. 12y equals, what's 4 times 4? Wait, did I do something wrong there? Y. Oh yeah, I did do something. What the heck? My bad. So my Y is gonna be to my 12. Oh no, my Y is to my 4. That's what I did wrong. Y to the 4 is equal to 12 to the 4. There we go. That's what I did wrong. So now I'm gonna cross multiply. 4y equals 48. What is 48 divided by 4? y is equal to 12. Is it? Yep, right there. Okay, so now let me erase this. The last one, let's find my z. So where's my z over here? Where's my z over here? It's from the 2 arc to the no arc. What's my other 2 arc to the no arc? So I'm gonna have z over 3.5. And now I'm gonna set that equivalent, I'm gonna set it equal to, once again, no arc to no arc. This one's been working out for me. So 12 over 4. So 4z equals, what's 3.5 times 12? 3.5 times 12 is 42. What is 42 divided by 4? Is 10.5. And look at that, it was correct as well. Okay? So this one is time consuming, but it's the same thing we've been doing, guys. You guys have to recognize what makes the side lengths similar to each other. We've done this a bunch of times. You have to follow 1 arc to no arc, 1 arc to no arc. So you know that these are the 2 similar ones. So that means this and this are going to have a scale factor that's going to be able to go back and forth to give you the measure of the side length. We've talked about that. Okay. So let's go over here. The polygons to the right are similar. Okay. So they're similar. So that means in order to find my x and my y, I can actually use proportions, right? I can use side length proportions. Okay, so to find my x, so I can do this small triangle to this giant triangle. That's my two similar triangles, this triangle and this triangle. So my x is to the, I can do 13, to the 13. Sorry, my x is to the 13. My x is to the 13. Oh, I apologize. My x is to the 48 as my y. What? Oh my God. Yeah, my x is to the 48 as my 13 is to the 52. Here, I'm gonna show you guys what I did because this one's kind of confusing. Okay, so this x is this side length is corresponding to this one. And this 13 is corresponding to this one. That's what I did there. So, and my x and my 13 are on the same triangle, so I did it across from each other. My 48 and 52 are on the same triangle, so I equated them across from each other. So now I'm going to cross multiply, so I'm going to have 52x equals, what is 48 times 13? 624. Now I'm going to divide 624 divided by 52, and that'll give me 12. And my x is 12, okay? So now let's do my y. So my y to the 20, y to the 20 is equal to 13 to the 52. So 52y equals 260. And 260 divided by 52, which is what? My y equals 5. And that's correct. Okay. So, this one, okay? Okay, cool, yeah. This one's kind of tricky. All right, so this one, it's telling me that the triangles are similar. So that's one big thing. So these triangles are similar. So that means not only are the angles going to be congruent, but the side lengths are going to be proportional. So that means one proportion of a side length is going to be the same proportion for the other one. Okay? So this GD over MH, this GD to the MH is going to be the same as another proportion. What other proportion could we be talking about? Well, let's figure it out. So GD to the MH, can we also say we can also have DF to the HK? So DF is what? DF is 385 to the 245. DF to the HK. Because this is my what? So, sorry. This is my DF to the HK. Well, isn't DF to the HK going to be equal to GD to the MH? Yeah, because since the triangles are similar, I know that DF to HK is equal to GD to MH and is also equal to GF to MK. Okay? So now, so that means whatever this simplified version is, should also be the value of my GD over MH. So what is 385? Let's just do it step by step. What is 385 divided by 5 is 77. So let's divide by 5, because I know they're both divisible by 5. So I'm going to have 77 over, what is 245 divided by 5? 49. I know the other greatest common factor of 77 and 49 is 7. So what is 77 divided by 7? 11. What is 49 divided by 7? 7. So that means my ratio, my proportion of DF to HK is 11 over 7. And since the triangles are similar, that means that if this DF over HK is 11 over 7, so much GD over MH. And look at that, it is. Okay? This is very important, so I'm gonna, if you guys don't understand, I'll go over it in class again, not a big deal. But that's a really good question, okay? So, isn't this the same thing? Very similar, right? So, okay, find MK, okay? So, there we go. So, MK, look, let's look over here. MK is congruent, or KM is proportional to FG. So that means this is going to be proportional to this guy. And in blue, what else is proportional? Well, let's take a look at DF. What is DF proportional to? DF is proportional to HK. Cool, HK. So that means if I set up these two proportions, then I'll be able to solve for my MK. What's my MK? Let's get a value of X, okay? So now I can write GF, right? GF, oh my God, okay. GF to MK is equal to DF to HK. What is GF? GF, we already established, GF is 71.5. MK is X. DF is 154. And, oh, whoops. Was I supposed to put HK? Yeah. HK is 98. So let's cross multiply. Let's cross multiply our extremes and our means. It's going to be 154x is equal to 71.5 times 98. Wow, 7,007. Now divide by 154. 154. My x is 45.5. And that is indeed our answer. Whoops, why did I put 4? 45.5. Okay. What about this one? Okay, so they're telling me that the triangles are similar. Okay, so that's good. Find the value of x. Where is my value of x? It's on a side length, so I know I'm gonna need to use the property of similar triangles that tells me that the side lengths are proportional. Okay, so find the value of x. Okay, give the scale factor of the left triangle to the right triangle. Okay, that's fine. So let's take a look. WL. Okay, first, I don't want to go through all 3 if I don't have to, all 3 pairs. So what am I looking for? I'm looking for WJ. Okay, so I'm looking for WJ. So what is congruent to, or what is similar from this triangle to this triangle as WJ? Well, WJ is similar, is corresponding, I should say, corresponding to QV. So I'm gonna put WJ is corresponding to QV. And now I get to pick which one do I want to do. I need to compare one pair of corresponding sides, of corresponding side lengths, to another pair of corresponding side lengths. So I already have WJ is corresponding to QV. Now let's pick another one. Does it really matter which one I pick? No. Why not? Because these are isosceles triangles. So this value is the same as this value is the same as this. So let's just pick WL. WL is corresponding to what? QB. So WL to QB. Now let's plug in what I know about these values. What is WJ? WJ is x plus 8 over what is QV? 5. That's equal to, what is WL? WL is x. What's QB? I know that if BV is 3, QB also has to be 3. So let's cross multiply. So I'm going to have 3x plus 8 equals 5x. 3x plus 8, 16, 24 equals 5x minus 3x minus 3x. 24 equals 2x. So my x is what? 12. So my x is 12. Is that true? Yep. So my x is 12. Cool. So now I need to find the scale factor from this triangle to this triangle. So what is my WL now? Let's just do the first one. Let's not complicate our lives, you know? What is WL? WL is what? WL is x. What was x again? 12. Okay. What is QB? QB was 3. Now, because I know that they're similar, do I need to even put the other ratios? No, because they told me that it's similar. So I know that the other ratios are also going to be 12 over 3. Understand? But if you guys want me to do it, that's fine. We can do it. LJ, what's LJ? LJ is also x, right? Because of the tick marks. So LJ is, what's x? 12. 12 over, what is BV? BV is also 3. And then JW. JW is x plus 8. What's x? 12. So 12 plus 8 is 20. And then VQ. VQ is 5. So what is the simplified version of 12 over 3? 4 over 1. 4 over 1. What is 5 divided by 5? Divided by 5? 4 over 1. So my scale factor is 4 to the 1. Okay? Okay, so this is a question I want to do in class because we should know this, but I'll briefly go through it. Guys, what they want you to do, what are the lengths of A, B, B, C, C, D, and D, A? So they want you to find the lengths. So what most teachers, I guess, would tell you is to use the distance formula to find out this B to this A. And we know the distance formula is some crazy x2 minus x1 plus y2 minus y1. Oh, I'm forgetting the squared, something like that. I'm pretty sure it's this. But even I, like, I rarely use this. Why? Because I can just find my hypotenuse. Guys, if I were to draw an invisible line over here, an invisible line over here, what is this AB now? Isn't this AB just a hypotenuse? Because I drew a straight line down and a straight line across. And what does that form? A 90 degree. And what do I know about my hypotenuse? It's the side length opposite to the 90 degree. So now, what is the formula that we can use to find out any length of a right triangle? It's the most popular theorem in math. It's the Pythagorean theorem. What's Pythagorean theorem? A squared plus b squared equals c squared. Does it matter which one is my A? This one or this one? Absolutely not, because they're being added. So what does it matter which one's A and which one's B? So what is the length of this down one? It's just 2. What is the length of this one? It's just 1. So let's say that this was my A and this was my B. Okay? Well, what is A squared? 1. What is B squared? 4. My C squared, my C is the one I don't know. I don't know this length yet. That's what I want to find. So there's going to be 5 equals C squared. What's the square root of C? It's just going to be C equals square root of 5. And that's my first answer. Now, you don't have to do this all over again. Because what were the two side lengths of this right triangle? I guess you would say the non-hypotenuse, right? Or the legs, right? Yeah, you could say legs, right? I don't know. What are the two sides? Not the non-hypotenuse. It was 1, 2 units and then 1 unit. Well, let's do it here. 1 unit, 1, 2 units. So if this is just 1 and 2, what's going to change? Nothing. So this is also square root of 5. Look at this. 1, 1, 2. So this is also going to be square root of 5. 1, 1, 2, square root of 5. Now, a lot of kids would say, but Mr. Look, you went down -2. This actually should have been a -2, Mister. You actually did this wrong because this should be -2 because you went down. Okay, fine. What is -2 times -2? Positive 4. So it didn't change. It doesn't matter if I go this way, this way, this way, or this way, as long as I keep the same units, which is 1, 1, 2. 1, 1, 2. Okay? So all my answers are this. Okay. Name the isosceles triangles. Okay, so this one's pretty tricky. So in blue and orange, I'll draw out my parallel lines. This parallel. This is parallel. So now, you guys remember, this is just, you gotta look at this. You gotta look at it, okay? So, I have this giant triangle. Any one of these can be my transversal, right? But let's first take a look at the easiest triangle we can see. What is guys, there's multiple triangles here. There's this big one. There's 2, 3. That's it, right? 3? Okay. So there's 3 triangles. Okay? So this triangle is obviously isosceles, right? Look, Y, W, U. Y, W, U is a right triangle. Why? Because I have 2 what? 2 base angles. So I know that W, Y, U, some combination of that. U, W, Y. Okay, perfect, the first one. So now, what are my other ones? Guys, what do I know? I can start attributing in blue. I can start attributing different things. So I know that YZX also has to be 1 arc, correct? Because of what? Alternate interior angles. Okay, what else? Right here, look, this one, right? Because alternate interior angles. So now, what other isosceles triangle do I have? XWV. XWV. Isn't this just an isosceles? Because this is 1 arc, this is 1 arc. So XWV. Where's X? XWV. Okay, the second one. So now I've proven this one and this one. Now we just have to find the next one. So, right here, I found it. This is going to be corresponding to this one, is it not? If we were to draw this out, wouldn't this and this just be corresponding angles? So now, what else is my isosceles triangle? X, Y, Z. X, Y, Z. Isosceles because of the base angles. X, Y, Z. Okay? So this one's tricky. So make sure you study this one, okay? Okay, what about here? Okay, they want me to find the measure of A. Okay, so they want me to find the measure of A. Okay, well, let's see. Okay, so it's probably going to be helpful to draw out your parallel lines. Okay, so let's see what I'm looking at. Okay, I already know this is going to be one arc because of I already see the corresponding, right? So corresponding. So I know I have this. Don't I also have corresponding right here? Yeah, here and here. Corresponding. So I know that my other arc is here. So now, I can't find this one directly, but I can find this one. These, right? I can find, I guess I should have circled, I can find this angle and this angle. And if I'm able to find either of these angles, then won't I know this one as well? Because they're just one arc. And what do we know about the same tick marks or the same number of arcs? Same number of tick marks, same number of arcs. It means the angles in the arc's case are congruent and the side lengths in the tick mark case are congruent. So how do I find this one? Well, I don't know this one or this one, but I do know that they're the same. So I'm going to give this a value of X and X. So if I take a look at this triangle right here, what type of triangle is this? Isosceles. That's even more, look, it's like what we did before, this isosceles. So now I'm going to use the triangle angle sum theorem. So what is X plus 42 equals 180? 2x minus 42 minus 42, 10, 7, 138. And what is 138 divided by 2? 138 divided by 2. X is 69. So is it 69? Yep, right here, 69 degrees. Perfect. So that's how you find examples, angles. Okay? So that's the end of 7.3. We